Greetings, this is Anthony Dick, and this is just a walkthrough of the test 2, benchmark number 2 test, practice tests online. Number 1, multiply these polynomials. So this I've got to do the distributive property. So I'm going to multiply negative 2x squared times both of these. Remember, when I multiply these, I multiply the coefficient times coefficient, so negative 2 times 3 is negative 6. And then x squared times x, I add the exponents, and there's a 1 there. 2 plus 1 is 3, because I've got 3 x's. Negative 2 times negative 2 is positive 4. That has an x squared, that has nothing, so it's just an x squared. Okay, there's lots of different ways to organize this information and present it. All that really matters is that you combine the things that are alike and put it together in the end. Negative 3 times 3, so negative 3x times both of these. Negative 3x times 3x is negative 9x squared. I'm just going to start stacking my like terms. I like to do that. Negative 3x times negative 2. Negative times a negative is positive, and I just get positive 6, and there's just 1x. 1 times 3x, 1 times 3 is 3, so 3x. And then 1 times negative 2 is negative 2. The way I like to do it, I've stacked all my like terms, so I've got negative 6x cubed. Negative 4 minus 9 is a negative 5x squared. 6 plus 3 is a positive 9x. And minus 2, it's in standard form. I haven't forgotten anything. There's my answer. That's a horrible box. Okay, simplify. Now, I'll bet the number one mistake I see students making on this problem, most common one, is because there's parentheses, they think, oh, we're multiplying. Whatever person told you that parentheses always mean multiplication was dumb. They don't. In fact, most of the time, they don't mean multiplication. They only mean multiplication when they're sitting right next to each other. In between this and this, I see this minus. That means this is being subtracted from the first thing. Now, remember, when we subtract, the easiest thing, that subtraction is just going to change all of these signs. So I'm going to just go through and change all of them. Plus goes to minus, minus goes to plus. This plus just goes to a minus. This minus goes to a plus. And this 3x squared is now a minus 3x squared. And that changes that. So I just change all of these signs. Now all I'm doing is combining like terms. Now, I start looking for like terms. And I just make a quick precursory glance. And I notice that the highest thing is an x to the fourth. I mean the highest exponent. So I'm going to look for another x to the fourth. No, yes, there it is. No. So those are like terms. Negative x to the fourth plus x to the fourth. They're going to cancel. That's convenient. Now I'm going to look for an x cubed. I'm trying to get it so that when I write it down, it's going to be in standard form. An x cubed. No. There's one. And it's a negative 2x to the cube. Negative 2x cubed. Not x to the cubed. Negative 2x cubed. Okay, so that one's now been used. X squareds. I see one immediately there. 13x squared. Another x squared. There's another one. And that's the only one. Don't assume that there's only the two. They could be repeated. 13 minus 3 is a positive 10x squared. Okay. I don't like that green mark there. There we go. That looks a little better. Okay. 3, 2, 1. So just x's. There's one, and there's another one over here. So negative 2 plus 3. Negative 2 plus 3 is positive 1x. Now, I don't need that positive 1. If you happen to write it down, it's not wrong. But remember, when we're adding these things, all we do is we add the coefficients. And then my last set of like terms, I've got this negative 4, and it's a lot like that minus 4 over there. Negative 4 minus 4 is negative 8. And there it is. So even though there's just an answer there, there's actually a lot of thought that went into there, right? Okay. Expand. X minus 1 cubed. Well, x minus 1 cubed means x minus 1 times x minus 1 times x minus 1. Do not just try and pop this off in your head or go, oh, that's x cubed minus 1. That's probably another really common mistake. Okay, now, when you're multiplying three things, multiply the first two. So x times x, that's x squared. Negative 1 times, so x times x, negative 1 times negative 1, that's a positive 1. Okay? Plus 1. Negative 1 times x is negative x. X times negative 1 is negative x. So after I've distributed that times that, I get these negative x's here. That's negative 2x. Okay, now you've still got that times x minus 1. Okay? So this is something I kind of tucked up in the corner because I knew I was going to be combining some like terms there. And I wanted to have lots of room to look at this because this is much like that first problem I did up there. So x squared times x there, that's x cubed. X squared times negative 1, that's negative x squared. Negative 2x times x, that's negative 2x squared. Negative 2x times negative 1, that's positive 2x. 1 times x, that's positive x. And 1 times negative 1 is negative 1. Put all my like terms together, and I get x cubed minus 3x squared plus 3x minus 1. And there is my final answer. Okay? The biggest problem I see is people will do something like that, and they just apply that power to each term, totally ignoring the fact that means that's multiplied by itself repeated times. Let's look at something else. Next problem, number 4. Simplify this, write positive exponents only. Okay, now I'm going to zip through this really quick, and first, I want to break this up into problems. I'm going to deal with the numbers, then the x's, then the y's, then the z's. 28 over 21. You know, I really don't want to think right now, so I'm just going to type 28 over 21, and my calculator says that's 4/3. Okay? Sorry, I'm being lazy. Really, it's 4/3 because each of these are divisible by 7, and 28 divided by 7 is 4, 21 divided by 7 is 3. Now, I look at my x's, x cubed over x. 3 minus 1 is 2. That tells me there's x squared on the top. Remember, when I divide exponents, I subtract their powers. 4 minus 2 is 2. That tells me it's y to the second, and it's on top. Positive means on the top, negative on the bottom. Here, 2 minus 5 is negative 3. That tells me it's going to be on the bottom. That's what the negative tells me. And the 3 tells me it's going to be the power of 3. That's it. Okay. What's the difference between negative 2 to the 4th and negative parentheses negative 2 to the 4th? Well, negative 2 to the 4th is negative 2 times 2 times 2 times 2. That negative is not being brought to the power, only the 4. That makes this a negative 16. Negative 2 to the power of 4 is negative 2 times negative 2 times negative 2 times negative 2. That makes a positive 16. In this one, negative is not in the power. This one, the negative is in the power. How we're going to explain that. Okay, I'm sorry. So that's your deal. Is the statement 4x to the power of 2 equals 4x squared always, sometimes, or never true? Wow. Explain how you arrived at an answer. Is it always true? So I'm thinking, what's the difference between this? Well, this 4x squared is the 4 is caught in the parentheses. Well, I can tell you one times when I know it's true. When I'm looking at things like this, I like to think about 0. If I put 0 in here, 4 times 0 is 0. 0 squared is 0. 0 squared is 0. 4 times 0. So I'm just looking at order of operations. 4 times 0 squared equals 4 times 0 squared. That's true. Okay, so never true, that's not there. What if I put another number in it, like, I don't know, a 1? Well, if I put a 1 in there, 4 times 1 squared equals 4 times 1 squared. 4 times 1 is 4. 4 squared is 16. 1 squared is 1. 4 times 1 is 4. 16 doesn't equal 4, so not true. That tells me sometimes. Why? There's somewhere it's true and somewhere it's not. That's really all I have to do to establish something is sometimes true. I don't care about the other things because I've got a place where it's true and somewhere it's not true. Everywhere else could be true or not true, but sometimes it's true. It's true there, not true there. So maybe it's not true somewhere else. Okay, but I really don't care. Explain the difference between 2x to the 0 and parentheses 2x to the 0. Guys, these three questions are all about what do these parentheses do to these exponents. 2 times x to the 0 is equal to 1 because anything to the power of 0, not 1, 1 times 2 times 1. So it's equal to 2 because no matter what I put in for that x, it's x to the 0 is 1. 2x to the power of 0 is equal to 1 because anything to the power of 0 is 1. Here, the 0 only applies to the x. Here, 0 applies to the entire term. There's the difference. And so no matter what, this is always going to equal 2. This is always going to equal 1. Okay, moving on. Now, when on those explain things, I'm not looking for an explanation, exact thing. I'm looking for, do you understand what the difference is? So illustrate what the difference is. Okay, now, these next couple things. Well, this, evaluate 8 to the power of negative 2/3. I could actually type that into a calculator, believe it or not. And, you know, I might just do that if I'm feeling lazy or bored or whatever. 8 to the power of negative 2/3. And I hit equal, and I get 1/4. Why is it 1/4? Well, 8 to the negative 2/3, that's just the same as 1 over 8 to the power of 2/3, which is 1 over the cubed root of 8 squared, which is 1 over the cubed root of 64, which is 1 over 4. Okay, now if you just said this equals 1/4, I know you've typed it in your calculator, and I'm not going to give you full things for it. But if you show some of these in-between steps, hey, I understand what this means. I mean, if you did like this and then 1 to the 4th, I think I'd probably have to give it to you because I have to see some kind of an in-between step. If you did maybe that and that, ooh, I'd be very impressed. Anyway, simplify then write in radical form. Q to the 5/12 or Q to the 1/8. Well, I know when I have exponents that are being divided like that, I'm going to subtract the power. So I go to 5/12 minus 1/8. What's 5/12 minus 1/8? I don't want to do fractions. Not right now. Sorry, I'm recording this like at 6:30 in the morning, and my mind doesn't want to work yet. 7/24. So this is Q to the power of 7/24. So you've earned that. That's a 24th root because that becomes the index. That's a power of Q to the 7th. Or I guess you could say it's this, the 24th root of Q all to the power of 7. Either one of those is correct. Okay? Now, let's look at the next one. It says I'm going to use that for problems 10 and 11. Marvelous. Write the equation in simplest radical form. Okay, so I got to simplify that. So cubed root of 54. I'm going to break 54 down. I'm just going to do that over here in my scratch paper side. 54, that's 2 times 27, and 27 is 3 times 9, and that's 3 times 3. See the 3 there? So I'm going to be able to pull a 3 out, and I'll leave some space in case I do other things. The 2 is left underneath there because this is a cubed root, so I need 1, 2, 3 things. X to the 5th. How many times 3 goes into 5? Once, so I'll be able to pull 1x out, but it leaves behind 2 because there's 3 and then 4, 5, right? Okay, 3 doesn't go into 2, so these are going to left. That's left there. 3 goes into 8 twice, so I'm going to pull out 2 z's, and 3 plus 3 is 6, so, and there's 2 left over then, so I get z squared. There. Convert it to exponential form. Simplify your answer so that it doesn't contain parentheses. Wow. Okay. So, now I'm not doing this. I'm simplifying this. So that's going to be 54 x to the 5th y squared z 8th all to the power of 1/3, because that's what a cubed root means, power of 1/3. Okay, now simplify so it doesn't contain parentheses. All that means is I've got to take that and apply it to every single one of those. So I've got 54 to the power of 1/3, x to the power of, well, when I have a power to a power, I multiply them, and 5 times 1/3, that's 5/3. Y to the power of 2 times 1/3 is 2/3. 8 to the power of 1/3 is 8/3. And that's it. Okay, simplify these. 2 times square root of 2x minus 3 times square root of x plus 5 times square root of 2x. Now, as I'm reading that, I'm looking and thinking, can I simplify that? 2 and x won't break down. X won't break down. 2x won't break down. So there's none of these I can simplify. So now all I'm done is I'm looking for like terms. Well, that is like that because they have the same index and the same radicand. So I just add the coefficients. 2 plus 5 makes 7 square roots of 2x. And that minus 3 square roots of x just tags along. Cool. Okay, next, moving on. 4 times the 5th root of 2x times the 5th root of negative y minus 3 times the 5th root of 3z. And I got to multiply. Okay, now remember, multiplying outside times the outside. So 4 times nothing makes just 4. And I've got the 5th root of inside times inside. 2x times negative y makes 2x times negative y is negative 2xy, because I'm multiplying number times number, variable, variable. And those variables don't combine because they're different. Okay, 4 times a negative 3, that makes negative 12. So now I'm multiplying this term times that. 4 times negative 3 is negative 12. And I've got the 5th root of, that's an ugly 5, but oh well. Inside times inside. 2 times 3 is 6. X times z is xz. I'm looking, can I break anything down? Not here. 2x and y, they're all prime. 6 came from 2 times 3, and I know there's not going to be 5 of anything I get out of there. X times z is done, and so you know what? That's done. I don't like that. That's dumb. Okay, write the following in simplest radical form. Your answer should contain no radicals in the denominator. 2 to the negative 1/2. Well, the negative tells me it's going to be like that. Okay, the 1/2 tells me it's a square root because the index is 2 and the power is 1. So there's the 2 and there's the 1. Notice I didn't have to write either one of them down. Now, simplify radical form should no radicals in denominator, so I can't have that. So I simplify that, remember, by multiplying it by the radical underneath itself or over itself, however you want to think about it. 1 times the square root of 2 is the square root of 2. Square root of 2 times square root of 2. Remember, when I multiply a square root by itself, all I do is cancel the root out. That's in simplest radical form. There's no radicals in the denominator, and I am done. Cool. Moving on. Rationalize the denominator and write in simplest form as a simplest fraction. 3x over square root of 5x squared. Okay, and I don't need that long thing there. Okay, so here on the bottom, see that x squared? I'm going to be able to pull it out. So I've got 3x. I'll be able to pull out an x, but that square root of 5 is still left there. Oh, check this out. I see this right now. I'm going to be able to cancel that x, right? So this is 3 over the square root of 5. Okay, Now I multiply top and bottom to get rid of that square root of 5. This is a lot like the last problem, by the square root of 5. And so I get 3 square roots of 5 all over 5. And I'm done. Because it's simplified, there's no radicals in the denominator. Okay, divide. Whoa, look at this. So I'm going to set up a tabular division problem here. Can't remember how many things I'm going to use. P minus 2, or how many columns, so I'll just make myself a bunch. That seems about right. And I put P to the 4th here. Okay, P to the 4th divided by P is P cubed. So because that times that's got to make this, and I know this. It's always the first term. Negative 2 times P cubed is negative 2P cubed. But I have a negative 4P cubed up here. What's the difference between negative 2 and negative 4? Yeah, a negative 2P cubed. I know that the diagonals have to add up to these terms up here. But I know this times P makes that, so P times a negative 2P squared. Make that. Okay, negative 2 times negative 2 makes 4. P squared times 2 is just P squared. These are my P squareds. I've got 4P squared. I need 7. So I need to add 3 more. And then 3P squared divided by P, that's positive 3P. 3P times negative 2 is negative 6P. These are my P's. I've got negative 13, so I need another negative 7, because negative 6 minus 7 makes negative 13. Negative 7P divided by P is negative 7. Negative 7 times negative 2 is 14. I've got 14. I needed 14. That tells me there's no remainder. And my answer is P cubed minus 2P squared plus 3P minus 7. Make sure you indicate what your answer is. Oh, there it is. Okay. Solve this radical equation. I isolate the radical. So I'm going to subtract 2. That gives me the square root of 2x minus 1 equals 3. Okay, now our radical is isolated, so I'm going to bring each side to a power. That power must match the index, remember. If that was a 3, it would be 3. 5 would be 5. So far, that cancels. And I end up with 2x minus 1 equals 9. I'm going to move it up here. 2x minus 1 equals 9. I'm going to add 1. Now it's just a simple linear equation like I've been dealing with since I don't know how old, but a long time. Divide by the 2, and I get x equals 5. Now, I must check the answer. Remember that? So I must plug that in. Square root of, I'm going to put it right back in here. 2 times 5 minus 1 plus 2 equals 5. Me think 2 times 5 is 10. 10 minus 1 is 9. So I've got the square root of 9 plus 2. Square root of 9 is 3. 3 plus 2 is 5. Check. Just somewhere to indicate, yeah, I've checked my answer. That's it. Okay? Remember, if it didn't work out, this could be an extraneous. It's either extraneous or you did it wrong. Okay, number 18. Number 18. Consider that radical expression. Negative cube root of x minus 9 plus 8 is 6. What would be the most efficient first step in solving the equation? Well, I've got to isolate it, right? So I'm going to isolate it by subtracting 8 from each side. So I'm going to get that equals 6 minus 8 is negative 2. I'm looking for that. There it equals negative 2. There. That's it. Okay. And if you really want to see this one, come in. I'll be glad to help you through it, but I'm not going to do it on this video. Thanks, guys. Bye.